If you want to be a medical researcher, we want to talk. If you're researching where to do your graduate studies, we need to talk. If you're serious about your research and want to do groundbreaking work, come join us at the frontiers of discovery and the frontiers of learning.
Morning, Narveen. How are you? Hey, guys.
Morning.
How are things? How'd the assay go?
Good. The isolate ELISA that I ran worked wonderfully. It confirmed the luciferase assay that we did the other week.
Beautiful. So that puts the package together, the results that you have.
Yep. I just need to repeat this one more time and it'll be ready to go.
Good. Then you're going to write it up?
Yes.
Publication?
Yes.
Excellent news. Good. So you're on a high for the rest of the day.
Yes.
Enjoy. I'll see you a bit later.
Okay. Thanks. You too.
The Institute of Medical Science attracts students from a number of different faculties, and it's able to cross disciplines. So you can have bioengineering in collaboration with medicine, with neural stem cell research, as well as be able to apply these to pharmaceuticals and biochemistry. So there's a huge broad range of people that are able to take advantage of the IMS, and you're able to, as a student, take advantage of what they have to offer in terms of a big faculty.
The big aim of our lab is regenerative medicine. We want to find a way of using these stem cells in the brain to cure diseases. Our lab is looking into things like stroke and spinal cord injury. But we think this is a very big up-and-coming area, and it's very exciting to be able to use these cells to try and cure diseases.
So my research involves functional magnetic resonance imaging and diffusion tensor imaging. Functional magnetic resonance imaging allows me to go into the brain of people non-invasively and actually study how and what they're thinking. By doing this, I am able to look at something very simple, for example, a finger tapping task, and by varying the complexity of this task, I can see multiple different brain regions being recruited.
I'm actually performing an expression assay, which is a protein detection method, doing a technique called Western. And what it essentially is using antibodies to detect protein expression. And with this machine, at the infrared machine, we can detect two different proteins from the same membrane. There's the green channel, which detects one protein, and the red channel, which detects the other protein, all in one scan.
The Institute of Medical Science is unlike any institute in Canada and perhaps few in the world. It's a graduate faculty at the University of Toronto that trains graduate students and MDs for careers in medical research. It's multidisciplinary, and its supervisors are among the best teachers and mentors a student could want. And their research is making Toronto one of the most exciting centers of medical discovery anywhere.
Research kind of gives you the opportunity to make a massive difference to large numbers of people. And for diseases like malaria that afflict 500 million people a year, and tuberculosis as the leading single-agent cause of death in adults, I mean, these are diseases that have a massive footprint on human health and human prosperity. So an opportunity to try and make some difference to those diseases is certainly motivating and compelling.
So our research group tries to understand how we can improve the survival of patients who have major car accidents. We do this by looking at the spectrum of research opportunities, going all the way from understanding cellular and molecular mechanisms at one end, and then translating them through to the care of patients at the bedside. And by doing this, we can actually take bench research all the way to the patient and therefore improve their outcome.
So if you think you're having a heart attack, you would like to know that the paramedics who arrive at your door are applying the best science to their care. We have a huge sample size generated by the population in Toronto and the adjacent regions.
So my story is a little bit of a complicated one in that I started out in engineering and subsequently went into medicine. I really grew fond of pediatrics throughout my medical training, and so wanted to really devote my efforts to helping children with disease. but I also fell in love with global health and international health and all the diseases that affect the developing countries. And the fit with pediatrics is particularly good because the burden of illness, particularly infectious diseases, is highest in children.
I researched the side effects of antipsychotic drugs. A number of the drugs that they give schizophrenia patients cause a lot of metabolic disorders, obesity, type 2 diabetes, and I research how and why that's happening.
I'm doing my Master of Science in the collaborative program of biomedical engineering. I get a lot of hands-on experience in this lab, dealing with patients every day, doing complex analysis, signal processing. So this lab gives me a very good compound and combined flavor of different things to do.
Now for me, I chose a faculty member who was actually conducting research in my own home country. So what that means to me is that I can actually make a difference to people in a different country through research that's conducted in a world-recognized university.
So this year I won 2 awards. One was with the Institute of Medical Science, and it was an entry award worth $5,000. And it was given to all students coming into the program with their 3.7 GPA. And the second award was from the Banting and Best Diabetes Center because I do diabetes research.
It was actually a shocking thing to walk in, and there's a lady at the reception by the name of Hazel. You walk in, she knows your name. So for me, it was a little bit startling that coming in out of all the other thousands of students that possibly applied, I'd walk in and somebody knows me by name.
So when I was going through the U of T website, looking for various possible departments to apply to for graduate studies, IMS caught my attention because there were a lot of principal investigators that were not located on campus and are actually set up their labs in various hospitals.
Pursuing questions using the scientific method is a very different process than I'm used to in clinical medicine, so that's very rewarding.
My own laboratory, we interact not only in the research arena, but also socially through a variety of picnics, barbecues, and other social activities. So they do become a part of the family. I tell my lab members that consider this is your lab, and each individual person's success will help not only him or herself, but actually the lab entirely.
So the whole program is excellent in the sense that not only is it prestigious at a prestigious university, but you also have great faculty, amazing research, and they really do take care of the students, and I think that's what makes IMS so great.
Toronto provides wonderful opportunities for social outreach, for social involvement, great restaurants, great shopping. So all in all, it was the perfect choice for me.
And it's so supportive of students, no matter what kind of background you do have, that I wouldn't choose any other place over this.
We hope this introduction to the Institute of Medical Science will encourage you to learn more about us. Because if you crave challenge, love hard work, and think out of the box, what better place to be than at the frontiers of discovery and the frontiers of learning?